I think I'll get started. So I'm Eric Brown, and I'm new to CSU to start here in November, and really happy to be part of the engineering department. And today I'm going to talk about humanitarian engineering, which is an area that I've done some work in, and even my PhD was focused on sustainable community development. So basically, work in this area. Let me talk about my background before that, because it's kind of an interesting for me, like how did I get from what I was doing to doing humanitarian engineering? And so there's a picture of the Hubble here on purpose because I did a project actually to service the Hubble telescope with new batteries and solar panels when space shuttles were grounded. So I was working in aerospace quite a bit. And that was the Hubble robotics project, which was an interesting project because Congress paid for it and the shuttles were grounded and we were working on it. And then Congress said, we're actually not going to do this project. We can stop and work on it. We paid for it. You can imagine how unmotivating that is. But still interesting technology and fun to work on. I also worked on GMI, which is when you see that atmospheric river stuff coming in from the Pacific, that's usually GMI satellites. There's 6 satellites in a row that give you kind of real-time view of weather stuff. Probably the biggest project that I worked on as far as exposure to the public was the Mars Curiosity landing mechanism, which also was used on Perseverance. That was a very cool, very difficult engineering challenge. We kept saying, we hope it works. And then the boss would say, hope is not a strategy. This is $3 billion that has to work. It's an autonomous plan. So here's what we worked on there. There's the Mars Curiosity that weighs about 3,500 pounds. So the old ways that we've used for using the previous Mars missions wasn't going to work because it's too massive for that. So they developed this new methodology. And up above, that's the thing that my team worked on. There's this motor surrounded by resistor banks that dampen the descent of the Curiosity. Actually, I have a kind of cool video here on the show. It's everyone likes space stuff. So I won't go through the whole thing, it's 3 minutes long, but basically this is Perseverance, same landing mechanism. So it's a more updated video, shorter too. It takes about 8.5 months to get from Earth to Mars. And it's a 4.5 minute delay to get like a radio signal. So you can't really control the landing from here. It has to be autonomous. And so the way that both of these worked is it kind of came into Mars and it has this heat shield. And as it enters the atmosphere is much thinner than Earth's atmosphere. So it's the parachutes that they used for these were the biggest that humans have made. And they still weren't enough to really slow down the Curiosity landing. And so they had to use this other very complex, in engineering, we're always trying to keep things simple. This landing sequence was very complex, but it worked twice. So who am I to argue with that result? But anyway, it comes in and it's cool. And fast forward here. There's the parachute that I talked about. And then the heat shield, it's kind of jettisoned and the thing comes out and it starts rocketing around. So many different things that can go wrong. And it has this camera that looks for a nice place to land where there's not rocks or boulders or other things and interesting features. And it sort of hovers above that spot for a bit. And then the part that I worked on, there were 6 engineers on the part that I helped develop. It lowers gently, is the idea. It lowers the rover down. Figure out there it is. And then the rocket jettisons away, so it lands on top of it. And it can be discovered by Matt Damon later on in the So I got to work on this really cool stuff that went to space. I worked at the National Institute of Standards and Technology on superconductor testing and looking at how to advance those materials and stress rate effects, et cetera. But I also have done a lot of travel, and in that my travels, I recognized that there was this disparity between people, right? People were living in really bad conditions. I actually took these photos in India. And the photo in the middle was an amazing experience. I went to the school and they would make lunch for children, 6,000 lunches at a time, 2 different shifts. And I thought, what's the engineering that goes to make 6,000 lunches twice a day? pretty incredible. I had to go see the kitchens. They had all these like pulley systems and big cauldrons and stuff. It was pretty cool. And so I sort of kind of started thinking, how can I use my skills to make a difference here? Not just like something on Mars that's far away and it's exciting and fun, but what can I do that actually impacts lives here? And I went to an EWB, Engineer Without Borders conference down in New Mexico, or it was actually in Arizona. And I learned about Bernard Amade, who was the founder of EWB. And then he lives in Boulder, and I live in Boulder. And I ran into him at McCutcheon's Harbor. He was buying a snow shovel. And
all good things, a lot of good things happen.
Yeah, McCutcheon's is a great place. And so he invited me to his office to see what he was doing. And then he offered me I could be his PhD student. And that was kind of just out of the blue. And I thought, okay, I'll take this opportunity. And so Bernard became my mentor, and I'm still friends with him. We went to coffee a couple weeks ago.
There, is that working?
Yeah,
okay.
that is. Thanks.
I think okay, sorry. So humanitarian engineering, maybe you've heard the term before and you wondered what it was. And I think there's a lot of different people putting out definitions of it because it's an evolving, emerging field. But basically it's problem solving to help underserved people. So vulnerable populations, marginalized people. It doesn't necessarily always involve technology because problem solving doesn't need to necessarily involve technology, but often it does. Often it's kind of the combination of technology, but with human input. It's human-centered. And so we have to ask, why do we want to teach this? That's one thing that I've had to argue in the past of my past institution, for example. Why will we teach this? And what we can say is that most of the engineering, education, work, et cetera, is for like 10% of the world. Like 90% of the engineering is for 10% of the world. Here's a good graphic for that. And that's the wealthy people. That's Europe, that's the US, that's Australia, right? It's cool widgets and gadgets and things that make life easier. And there's nothing wrong with that. That's cool stuff. But then there's also a big part of the world that is kind of missed in that work, right? That doesn't have things like clean water and access to sanitation, or access to energy that's consistent, or good shelter, or access to healthcare or education, which means they're less resilient to crisis. So here's some sobering statistics. If you look at around the world, 2 billion people don't have access to clean and safe drinking water. 3.6 billion people lack adequate sanitation services. We look every day, 25,000 people, including more than 10,000 children, die from hunger and related causes. We can look at like how access to energy. The number of people around the world who live without electricity is nearly 776 million. We also say that right now this is a growing number. 2 billion people, or a quarter of the world's population, live in conflict-affected zones. So that's sad stuff. And I think that there is problem solving, especially from a systems perspective, that can address some of these issues and help alleviate some of the suffering. All right, so we were talking about earlier about the disparity that I witnessed and that exists in the world. And this is the World Bank income groups that shows kind of where people have wealth and where people are less wealthy. Like low income, I think the extreme poverty index is below $1.90 a day now. So we're making less than $1.90 a day. That's low income, like the blue countries. And of course, the Earth's not all in darkness at the same time, but if you were to transpose a satellite image, you can see that there's a correlation between where people have access to electricity and where people are wealthy, right? Look at that overlap. It's pretty well aligned. So a lot of the issues are exacerbated by our global population growth. Right now, we're 8.1 billion people and growing. And where is that growth happening? Right now, there are about 1.2 billion people in Africa, and by the end of the century, there'll be over 4 billion people. That's projected. And that's where, by far, the poorest continent at the moment, with a lot of challenges for livelihood and well-being that we've talked about for humanitarian engineering. Also, we have to think about these problems globally sometimes. So for example, increased population equates to increased energy demand. Increased energy demand means climate change. And developed countries are disproportionately contributing to greenhouse gas emissions at the moment. If we look at this is what we're using in the world right now for our fuel sources, and it's changed slightly because of global politics and what's happening, like in Ukraine, for example. It's changed. A lot of coal factories have come back online in Europe, for example. This is I just thought this is an interesting slide. You look at who's consuming, right? This is the world for oil consumption by nation, and the United States is like 25% of the world's oil consumption. And per capita, we consume 10 times the energy of all other countries. And we can see how that's affecting. I mean, it's kind of a conundrum, right? Having access to energy means well-being, but the way we're making energy is also contributing to not well-being, right? It has its consequences. So that's actually that's not Photoshop. That's actually me on a glacier in Alaska. And if you look really closely, there's someone climbing up the glacier in the back. It's kind of crazy, but that was a cool trip. But also you could see that these glaciers are disappearing, right? I don't know if you've seen the movie Chasing Ice. I recommend it if you haven't seen it. It's really interesting, where a guy set up cameras to film glaciers and you can see the recession. It's depressing and scary, but also important that we know about it. And of course, that means we're having more extreme weather events. Is it working out there? I see there's a comment. Okay. And what does this mean for humanitarian engineering work? The World Bank is saying that climate change is going to accelerate extreme poverty because these communities are already challenged and don't have the resiliency or the capacity to deal with the changes that are happening. So between 32 and 132 million more people will be pushed into extreme poverty below $1.90 a day by climate change effects. Also, 40% of the world's inhabitants reside in coastal zones, and 67% are low income by World Bank metrics. So again, we can look at an overlap of the poverty index and the countries most vulnerable to climate change, and it sort of aligns. So I think, though, engineers, we have a big role to play in this. We have skill sets that we're problem solvers. That's what engineering is about, right? So the idea is to create sustainable solutions that build capacity and resilience. That's what humanitarian engineering is about. So this is actually from the first UN summit, Earth Summit in Stockholm in 1972. And they said that we want to create secure and stable communities. And this is the definition they said, where basic human needs and rights are fulfilled, meaningful work is available. People have access to resources and knowledge, and they can sustain themselves economically, socially, and environmentally. So we have to ask, though, how do we do that effectively? There have been a lot of bad projects and well-intentioned, but they just haven't worked. So we try to do things in a participatory way, right? We want to ask, does the process used in the framework help community users generate information to solve problems they have identified, using methods that increase their capacity to solve similar problems in the future? And obviously, technology has a role, but if we only are approaching these problems through a technological lens, then that tends to lead to failure of the projects. So development aid has often failed. We're talking about complex systems. We have approached things from a reductionary way. Technology alone can't solve these problems. We need to recognize local context, and successful projects need to be participatory. I think something like 70% of the World Bank water projects in Africa failed within 2 years. And that's because they haven't taken into account or included the community in the process. If you just go in and bring in a well and drill a well, but you don't train anybody to how to maintain it or talk to people about the need for the well or involve them in the process where it's a good location, et cetera, it ends up leading to failure. It's like someone coming into your living room and telling you where you should move your furniture, right? So involving communities in the process is critical for success. So I think also, if you do it in a reductionary way, we've seen that doesn't lead to good outcomes. Systems thinking is actually well applied for these social types of problems. Because social problems are complex, they're hard to define. We have to sort of live in that complexity and accept it as part of the nature of these problems. And we want to look at how do we solve these wicked problems with solutions that improve the capacity of the communities, knowing that maybe our solutions aren't perfect always. So my PhD was in the at CU Boulder, and I got a certificate in engineering for developing communities through the Sustainable Community Development Program. And basically, it has to be a multidisciplinary approach where we're looking at people, planet, and prosperity, the triple bottom line on how do we approach these problems. So you've all seen the UN Sustainable Development Goals, the 17 goals to transform our world, right? These are replacing the Millennial Development Goals. And humanitarian engineering is involved with many of these, like WASH, that's water, sanitation, hygiene. How do we bring clean water to people? How do we make sanitation available to them? That's goal number 6. Or food security, right? That's goal number 2, zero hunger. Access to energy, that's goal number 7. And actually what we can see is that these goals are all interrelated, right? So systems thinking is well suited for these issues. I think it's important to recognize that these goals are well-intentioned and they have led to improvements in different communities, and it's a good unifying strategy, but local context is important and often ignored. Which means taking into consideration the participatory methods that I keep talking about, that stakeholder input, understanding local conditions, allowing communities to develop their own solutions, and being there to assist with our technology. This is a different kind of engineering challenge, right? We talked about space stuff earlier, and here you're talking about forces that a rocket and gravity pulling a rocket down. If you're looking at a community, there are multiple forces that are pulling it down. And the idea is, how can we improve, where are the leverage points in the community to improve that community's capacity? So there's a lot of different areas to look at, and I think it's important when we're doing these projects to understand different aspects of the community so that our projects are effective, and how those are interrelated, which is also well suited for systems thinking and a systems approach. So here's some examples of where we would consider systems approach and the interactions of the different components. Obviously, sustainability is environment, society, and economy. The triple bottom line, we've mentioned that a couple times. I also purposely picked the 3 UN Sustainable Development Goals earlier that were energy, food, and water, because often you hear about that nexus of the energy, food, water system. Also, there's a systems approach to look at food and nutrition security. So how do we approach these problems? One area that I've been really interested in is appropriate technology. These are holistic designs that look at local context. It's usually kind of simple solutions. The interconnections of stocks, flows, et cetera. We have, of course, participatory methods in there again. It's important for that community input and that local context. The designs are human-centered. And so I'm just going to share a couple projects that I've worked on that they're kind of fun to talk about. So I did a study abroad class in Costa Rica. That's about a third of the students, and they're building a little road so that It's not muddy, it's easier for the community to use. But before I went on that project, the students all asked, what are we going to do? We're going to work on an energy project? Are we going to work on a water project? And my answer to them was that we have to ask the community what their needs are. And so surprisingly, what the community expressed was that the biggest problem is monkeys were stealing the chicken eggs. And so the students actually built a box for the hens to lay their eggs. They would funnel the eggs into a monkey-proof area, a monkey-proof box. And so everybody was really happy about it, except for the monkeys. Also had a 100K Strong for America's grant. That's a grant from the State Department that's about promoting collaboration and building relationships among the Americas. And I took 10 students to Mexico, and we worked with 10 Mexican students there. So we had 10, and also faculty from the US and faculty from Mexico. And we did some humanitarian engineering projects there. This is a water collection system from the roof at the school there. We did some indoor air pollution mitigation stuff. We built them a bathroom. There was a community didn't have it, like people were just open defecation in one area, so we built a bathroom. And then also what was cool about this project is it was a true exchange program. The Mexican students came to the US as well. And we went up like Trail Ridge Road and had a snowball fight. They had never seen snow before. That was really cool. And we talked about that cross-cultural understanding, and we really built cool friendships. My favorite part about this project was I went back to Guadalajara, to UNIVA, was the university that I was partnering with for spring break. And I ran into my students there who had been on the summer class before. And they had used their spring break to come down and continue these projects with the group there on their own. And I thought that was really cool. Also, this student started an organization called Veterans Without Borders that kind of spurred out of this. He kind of realized this is the first exposure he had to humanitarian engineering. And he said, hey, this is like actually something that speaks to me. And so being, coming out of the army and he'd been in Afghanistan and stuff, he wasn't sure what his next path was. And this is his new path. So that was really cool too. After the earthquake in Nepal in 2015, it wasn't really a good idea for a bunch of people to come in there as development workers and crowd things when there's already resources that are strained because of the earthquake. So we built a biosand filter that we tested in the EPA certified lab at the university. We had one student who's from Nepal. He wrote the instructions in Nepalese, and we also had pictorial format instructions. Sorry. And we sent those to an NGO so people could build their own water filters and have clean water after the earthquake. When we talk about appropriate technology, sometimes it's not clear what makes something appropriate. So I worked with a colleague, Michael Bauer, on a project. It was actually his master's thesis.
How are you?
And we looked at how do we have an assessment tool to assess the appropriateness of different projects to help make decisions for which projects will be the best. And so we looked at multiple criteria development or decision assessment, which is good for AT. Looked at a meta-analysis of the literature and said, well, how often are different terms used? Like community input was on almost all of the literature. And so we did weighted values based on how often those terms were used, and built a tool that did like a ranking of those based on community input, saying what they thought about the different project options. And when they used those words, it gave weight to that tool, and then it would give an appropriate index. And we tested it, or we used it first as a case study in Westwood, Denver. So Westwood is a pretty poor neighborhood, and has a lot of marginalizing factors. And so we met with community people there and got different data to figure out what are your challenges. And these are some of the statistics we found for Westwood. So I want to point out that this is humanitarian engineering right here in the US. You don't have to go to faraway places to find people who are vulnerable and need help, and where these kinds of solutions and this methodology can help them. And these are the community needs that we that we ranked, economic needs, violence or negative influencers, et cetera. And we decided to focus on the housing stock. Most of the houses there had really high energy bills, and the rent was lower, but not that much lower. So the energy bills more than offset the savings in rent. And so we thought, what's a good option to address this? So we did different potential options. We looked at solar furnaces, PV panels, just keeping the traditional furnace, doing no change, supplemental space heaters, reducing heat use, improving insulation or efficiency. And then we looked at criteria and gave it a weighted score. And then this is sort of some guesses, right? You're making a lot of guesses. But have you heard of the Fermi solution before? So the Fermi solution, basically, Fermi was very good at predicting things. And if you have multiple considerations or inputs and you take reasonable guesses, you can come to an answer that's contextually correct. And so he was asked, for example, once to predict how many piano tuners are in the city of Chicago. And so he took some guesses. 6 million people in Chicago. It could be 12 million, it could be 2 million, but the factor in there is 2 or 1, right? He said, well, how many people are in a house? On average, 4 people, he said. How often did pianos, or how many houses have pianos? Every 10th house has a piano. How often do they get tuned? Every other year. How many hours is it? And so he went through this sequence, and he came up with 16 piano tuners, and there were 18. And so if you have enough different variables, and you can take reasonable guesses of those variables, even if you're off on some, it converges towards something that's contextually correct. And so that's kind of the idea between this multiple utility assessment matrix. And what we came up with was that the weighted scores showed that the supplemental solar furnace had a score of 221, and improved insulation or efficiency had a score of 217. The community had already tried doing like a package that gave you efficiency improvements for your insulation. It didn't work very well because they ignored some of the, it was sort of just like, here's a package, and there was no training involved and involving the people in the community. And so we went with the solar furnace. So here's what that looks like. It's basically a bunch of beer cans. You hollow out the cans, you pull air through them with a computer fan. The sun heats that air, and that hot air goes into the house and heats your house. And it looks really ugly. So how are you going to convince people to put this on your house? So that was a part of this project, was the social sciences part of it, the behavior change communication. So here's a picture of my students building some of these. Looks like they like Rolling Rock beer. Probably was the cheapest they could get. Here's what it looks like before the cover went on it. Because we're engineers, we kind of geeked out on stuff like computational flow dynamics. Where can you place the holes to make it work best? It's actually not very complicated. Right in the middle, works great. This is my student Ziola's. She sent me this when they were testing it. It was a cloudy day and they were getting 170 degrees output. So they work really well. And then we geeked out even more. We did data logging using an Arduino controlled data logger. We built a heat transfer model to sort of predict how they would work. And then we compared the output to the heat transfer model. And there's what we got. And if you look at that model there, it's matching pretty well towards the end of the day, but early in the day it's not. And that's because there was a tree that was shading the furnace. So, and then we sort of took that model and extrapolated how many BTUs could be produced during the day, and then predicted based on the size of the furnace how much money you could save. And so it's about $28 a month savings in ideal situations for a $30 to build device. It's pretty cool. NPR covered this story, actually. That was neat too. So then we had to convince the community the merit of these to make sure that they would use them, right? You had this ugly thing, and they all showed up and they were like, what is that? But once they felt the heat coming out, and it was like free heat, they loved it. They even named it Easy Heat. So I thought as soon as it was named Easy Heat, then they're on board with this. So then these are my students installing demonstration units on the house. This is a pretty cool project. The family brought us like lunch and stuff, and this little kid we put it on his bedroom. He's like, I'm going to be so warm in here now. He was excited. It was really cool. We sort of leveraged the Fogg behavior model. BJ Fogg is a behavioral scientist at Stanford University who has kind of come up with this model that says at the convergence of motivation, ability, and some trigger, you can change behavior. And so the ability in this case was these things are affordable. They're like $30 to build. The communities have the skills to construct the devices, and there are cans everywhere, so it's easy to make them. And for trigger, we purposely put the first demonstration models after the first cold snap. So it's been a really nice fall, and then suddenly there's a cold day, and everybody's like, oh no, we're gonna have a lot heavy, bills coming soon. And we put these demonstration units in, and everybody's like, this is great. And people became interested. So then we did a community workshop in the community there, and we thought, oh, maybe like 5 people will show up and want some, and 40 different families showed up. There were too many families to be able to build all of them. We didn't plan for that. But a guy who was there sort of volunteered that he would start a business to build them for people and charge them a little bit of money. So it's really had all these kind of tangential things that happened from this project. It was cool. So during COVID, everything got shut down, but I was running a lab at the time that had a giant 3D printer, and I saw this project that was happening in Italy, and I contacted them, and they sent me their plans, and then we just adapted them for our printer, and we 3D printed valves here that converted these masks into ventilators so that people who were suffering from COVID, and this is before there was a vaccine and we didn't know how to treat it, they would have this positive pressure that would help them breathe easier so they wouldn't have to get intubated. And we made 139 of them, and we donated them to hospitals. The Navajo Nation got 85 of them. And I got feedback from doctors that they were saving lives. So that's pretty cool. And that was when you could do this because there was emergency relaxation of the standards and the regulations. But there's your stuff right here. There are a lot of opportunities for innovation for emerging markets. This is the Tata Swatch. That can make, it's $22 initial investment, can make 3,000 liters of clean water it's about 200 days of clean water for a family of 5. That's pretty cool. It's an Indian company. Or having EKGs now, like the technology is like $80 for a handheld EKG. It used to be impossible if you were living in poverty to have access to that kind of health information. Or having a fridge that runs on batteries. How cool is that? Like, it's even called little cool. So not having refrigeration really has an effect on your health and your outcomes with the family. Or cleaner stoves, right? Indoor air pollution, big problem. 2 million people a year die from indoor air pollution. How do we produce cooking that's more efficient and better for people's health? And so CSU right here is doing awesome work in that area. Another area of humanitarian engineering that is also very interesting is assistive technology. My students were involved in some projects of this in the past. We actually went and worked with assistive technology partners in Denver, and they kind of expressed that their need was that some of their people who are born to have neurological dysfunction or issues, it's kind of compounded because if you don't have movement, your neurology doesn't develop when you're in that younger age. And so our students went and built this thing that could kind of move. You could put like a wheelchair on it or had a seat on it, and it can move and had big buttons. So if someone had challenges with small controls, they could kind of hit these big buttons. And then they decorated it to be a pirate ship because it was for kids. It's pretty cool. So assistive technology, there's a lot of potential humanitarian engineering stuff in that area. But I think it's also important when we're talking about these projects to talk about ethics, right? We want to avoid the white savior complex, for example. You want to build trust within communities, and you want sustainable solutions to solve the problems communities identify. So we're talking about sustainability, social justice, environmental justice. And this is an actually interesting area too, engineering for peace. And systems thinking, I think, can be useful for looking at ways to promote peace. Because when you have conflict, you're talking about complex systems, and where are those leverage points where you can make an impact that might promote a better outcome for promoting peace. I gave a talk actually at the Peace Institute about this. So these are complex problems, and systems engineering is involved with complex problems, right? So this is, I think that if we're doing this from a reductionary way, we've seen that that hasn't worked well. 70% of water projects failing in Africa within 2 years, for example. So I think systems thinking can be useful for doing these solving these issues. And we need to look at things through a different paradigm. And actually, these pictures are actually very personal to me. The one on the right there, that's Santa Rosa, California, where I lived for basically when I was like 14 to 21. And 2,000 houses burnt in one day in a fire there. The left is Paradise, California, which is where I rode my bike all the time when I went to undergrad at Chico State University. That was a pretty terrible fire. And I could put one for the Marshall Fire in here too, because that was about 2 miles from my house where the Marshall Fire came. So I actually abandoned my house that night because I was worried that my house might be engulfed if the winds shifted. So you've probably seen this quote before. And any questions? I'll open up to the floor to questions. So the question is, how did you decide to use a weighted MCDA versus Promethe, Electri, et cetera? Was that because you wanted community buy-in values to drive your DSS? And we just chose that because it was well suited, we thought, for the social part of that problem. I mean, there are multiple ways to do that, but we just thought it was well suited for that particular project.
Different levels of knowledge. And so that probably creates cases, you know, if you are involving community design of cook stoves, you know, what do you want to see in a cook stove? In general, they want to have a bigger mouth on the stove so they can use larger wood. And that doesn't work in terms of reducing emissions, but they're really not motivated as much by emissions and pollution. They are that isn't the driving value because they've always lived with smoke.
Right.
So this is one. Yeah. So how do you do you overrule that? How do you think about that?
So that's a really good question, and one of the methodologies that I've seen be successful is kind of implementing stages of change for behavior change communication. So stages of change kind of recognize that there's 6 different, usually it's for people who have addiction, stages of change, but there's 6 different stages that you go through to change behavior. And the first is like there's pre-contemplation. And that would be what you're describing. The community doesn't even realize maybe that the smoke that they're being exposed to is bad for their health, for example. And then there's kind of the contemplation part. Well, maybe now I've been told there's something bad about the smoke and I understand that a little bit. Maybe I want to start thinking about what can I do to reduce my exposure. And I think you kind of, as coming from the outside, you have to be very careful not to be like, we know better for you, or we're coming in to give you the solution. But you work with them to kind of develop that plan that might help them change that or adapt that technology. And I think stages of change is a pretty good model for that exact scenario. But also involving all the stakeholders in the community is very important too. And went to San Cristobal in the Galapagos. Went with Bernard on that trip there. It was a pretty cool trip. And we just met with like the mayor, we met with the priest, we met with the school, and we got input about what are the issues in the community. And really the main issue that they had there was that the water wasn't clean. And so kids were getting sick and they couldn't they would be at school and they wouldn't go to school. And then we had to find out, well, where's the water source being contaminated? And so we sort of just did some analysis of the water because it came down from the mountain in this one pipe. There's a break in the pipe somewhere. That's what they discovered that was causing that. In the meantime, we also said, well, what about doing some rainwater collection and kind of offering multiple solutions that might work for them? And actually, we stayed with it sounds like a pretty fancy name, the Grand Archbishop of the Galapagos. We stayed at his house. It was pretty amazing. And they had these showers with really low water pressure. And so Bernard and I raised the tank a little bit, so you had a little more gravity potential. And then they had better pressure, and they're like, it's a miracle. Engineering. So that was a pretty good experience. But yeah, I think involving discussion, and sometimes that even involves like getting together with people and having a roundtable discussion about these issues, and then sort of like introducing the idea of, have you thought about this? That can sometimes help promote the outcomes that you're hoping to get.
So Aaron, you mentioned the importance of humans, right? So what thoughts or guidance do you have for taking an engineer that is trained in quantitative, numerical math work?
Yep.
Giving them the skills so that they can bridge those cultural, sociological kind of, human elements to be able to open up the conversation. How do you turn an engineer into a humanist?
Yeah, that's a great question, and I mean we have a reputation as engineers for sometimes the way we approach things, right? But I think that if we're talking about from a curriculum standpoint, when we're training engineers, it's important to not just train technical skills. I think we have to introduce curriculum that involves thinking about things from a different perspective. And it's hard. I know, especially undergrad, you have so many units you're allowed to require. It's like 129 or something for the state of Colorado, right? That you're allowed to require. And how do you fit in statics and dynamics, and you have to take this class in heat transfer or whatever? Where is there room for this humanities stuff? But I think it's really important that we don't ignore that. It has to be part of the curriculum. And so I'm grateful that in our program, we have people like you who are very invested in that, who understand the importance of that human-centered component. So, both of you.
How do you decide on what community you're in? Because obviously there's humanitarian in tons of places, so that's a decision-making process that you have to go through. And what kinds of processes do you use to those?
Most of my projects have been invited, and sometimes, most of the time, there's been like structure there already that's embedded in the community, so there's trust already built, which makes it a lot easier to be involved in those projects. So the project in Mexico, for example, the university in Guadalajara, Oniva, had been doing work in that community for many years, mostly with like entrepreneurship stuff and small, like micro loans and things like that. So they were open to the idea of us being involved. The community in Denver, I worked with a NGO there that's called Revision, and they had done a garden project there. And the garden project was really successful and awesome. I went to their every year they have a harvest festival, and they have this giant garden, and the mayor came and spoke, and he said, he was in Denver, and he said, on this corner, every year or every week, the police used to come for a shooting or some sort of violence or some call every week. And now that we have this garden here, we haven't had any calls at all. It's that garden has transformed that corner. So what was beneficial for that project was they have the promotora model. Promotoras are kind of trusted community members who can distribute information, disseminate information. Usually it's for health stuff. That's how that usually works. But in this case, the promotoras, who I convinced that they named it the Easy Heat for the heater, they were able to go to the community and identify which households might want these on their houses and then spread the word, which made the project successful. So if you don't have buy-in from the community, you're not involved with the community, then it doesn't work. So I would say that mostly invited projects, or in the case of the Gorka earthquake, we just saw the need and we knew an NGO that was working there already, so we contacted them to do that project.
Thank you. Very interesting. So I'm from Nigeria, and I know that typically when projects like these are done in places like Nigeria, it's engineering. Technology plays a role in that. One thing with engineering is at some point during the life cycle of that system, it breaks down.
Yep.
And you have to fix it. And obviously, like a team like yours going in there to set up the system, you won't be there forever. You just get set it up, show people how to use it, and then leave. But how do you typically account for maintenance of that system? Because especially in places where they are not really very literate, and so teaching them, oh, this part is fault, this component breaks down, this is what you do, or especially like in the system where you might not have gotten every single part of the system in Nigeria, maybe you brought some from the US, getting those parts there, fixing it. How do you typically account for like training, people on how to maintain the system?
Yeah, that's what's been done wrong a lot of times. There's a good documentary called The Waters of Aol, which is about exactly what you're mentioning. And it shows a successful community development project for well drilling and contrasts it to the ones in the same area that weren't successful. And what it really highlights is that participation of the community in the process, training people in the community on how to maintain it, and awesome project. It was at the time guinea worm was a big problem in that area, and people would fetch water from like 3 miles away. Usually the girls in the community fetch water, and they carry this water back, and then you drink the water, and it's poison for you because you need the water to live, but it has guinea worm in it, and then that was causing a lot of obviously health issues. And so there was motivation, and this organization worked with the community to train people and also to provide supply chain for where to get the parts, and also to help the community set up infrastructure for like collecting money to be able to buy the parts, so the community was all invested in that pump, and it worked really well there. And then 5 miles away, there was a project that it's like how you described, where they just came in as engineers, put the well in, and it failed within a year or something, and then they were back to collecting water and having guinea worm. So there are methodologies like that work, but it really involves community involvement, and the local context is important. And there's not really a blanket way of doing things that will work in one village and not another for many of the projects. You have to be very adaptable and adjustable.
Speaking of that, there's some situations where, for example, it's maybe local government that says, oh, I think this community needs this. Like you said, you typically go there when you invite us to help out. And so they reach out to like your organization and like, oh, this community needs it. But then when you get there, it's a lot of backlash from the community. Like,
Yeah.
They don't necessarily agree with the local government.
Right.
In a situation like that, you just walk away because now there's no real community engagement. You just walk away. What are the options you consider?
I think it's how you come in and approach it initially. So I think that the local government is just one stakeholder. The community leaders, the people who live in that community are the main stakeholder, right? So you have to listen to all the voices, and in that case, come to a consensus on what might work. And also sometimes I've had projects where you're like, what do you need in your community? And they're like, we need TVs or something, and they're like, they don't have clean water, they don't have sanitation. And so then you have to gently say, well, that's not really what we provide, but what our skills, working in partnership, not coming in from above to be like saving you, but we learn a lot from the communities as well. It's definitely a partnership. How do we work together to come up with something that will work? I think a really good example was of this type of work was in Belize, and this is Bernard who did this. This is when he founded Engineers Without Borders. I love this story. he went down there and he saw that the girls were fetching water, which is almost how it always is all around the world. And because they're fetching water, they don't get to go to school, and it affects the well-being of the whole community. Everybody is impacted, right? And he said, we can use a ram pump here. There's no gasoline here. There's no electricity. We can't use an electrical pump. We can use a ram pump that uses the momentum of the water to bring water to the village. And then let's do that. So he came back to Colorado. He raised some money. He brought students down. This was the first EWB project, and they built this ram pump for like $2,000. And the outcomes for that village have been totally incredible, right? It's totally transformed the potential, the capacity of that village. So something like that is pretty cool. But he involved the community in even building it so that they would know how it worked, so that they could keep it repaired. Mm-hmm.
You mentioned that climate change may better cause poverty and some developing countries. I want to know how that is so. Is it that the governments may need to spend more resources on fighting climate change, or there are not enough structures in place for people to deal with the effects, like flooding and stuff like that?
Sure.
How is that any different in the developing countries compared to the developed countries in terms of poverty?
That's a good question. And the main reason is resilience. So if you're in a community that's struggling every day just to find enough food or to find clean water, then you don't have the things in place, the infrastructure or the systems in place to recover from disaster. And climate change is accelerating these disasters, right? So I'll give an example right here in the US. So let's compare and contrast the floods that happened in Boulder in 2013 to Hurricane Katrina in New Orleans, right? Some parts of New Orleans have completely recovered, and if you go to like down to French Quarter, it looks exactly like it did from before the hurricane. Other areas, the poor areas, are boarded up and abandoned, and they never recovered. And that's because they didn't have the capital and the infrastructure and the systems in place to be able to recover. Boulder is a very rich community, we know, right? You cannot find evidence that there was a flood in 2013 other than they put this pole up showing where the water level was, right? It recovered within like 6 months or a year or something, where there was just like, we have almost 100% recovered because they had things in place. They had money, they had capital, they had different components that make up capacity. And when you have capacity, that's what makes you resilient. So when we do these projects in humanitarian engineering, what we're doing is we're building capacity, which builds resilience. And climate change is affecting areas and will be accelerating extreme events. And so having that capacity in place will make a difference.
My second question is that is there, if you want to volunteer to something like this, how do you
Yeah, there is. Rams Without Borders, they just did a project in El Salvador. And that's that. I haven't been involved with them at all because I'm new to the university, but I saw this, I just read about their project and I thought that was really cool. We'll be offering a humanitarian engineering course this summer. I'm going to be teaching it. So if you're interested in taking that course, it's going to be through the systems engineering program. There also are professional organizations such as Engineers Without Borders. So even if you're not a student or something, you can get involved in their projects. There's Bridges to Prosperity. There's Engineering for Change. There are a lot of different organizations that really, really welcome the technical knowledge of engineers to be involved in finding solutions to improve capacity in vulnerable communities. Oh, sorry. Sorry. Thanks for joining.